Welcome to part 2 of Farm Radio Panasonic R-111 repair disassembly. So far we removed one screw, one washer, a hidden screw under the earphone, and another washer corroded. The hex nut on the speaker and the associated bracket and the neck strap or hand strap, whatever you want to call it, and the earphone fastener, and that's where we're at. This is real delicate around here. You have your antenna. Try to get this out of here gingerly without breaking anything. So what we're looking at here is our power wire, which is ground. We'll disconnect that. The antenna I'm going to fasten with some tape or something to the dial so I don't move that around. Our negative speaker terminal and our positive speaker terminal, or whichever way it's listed here, it's going to go from the earphone jack, and basically same with the other speaker connection, from the output of whatever to the earphone jack. Okay. So basically I would not even try to attempt to find out where these antenna wires go if they happen to break off. I don't even want to think that. Little shot in there. All corroded around there. Let me label these wires here with some color coding. 1, 2, I think 3, and this one's over there. A little more on the R-111 Panasonic transistor. I've cleaned the power switch there. I'm going to try to unsolder. I'm just getting some visuals here. They have all this copper wire running under here, which is somewhat a concern, but I hope it's coated because it's running all over here. It's running over here. I labeled the antenna green, like pink. It's just copper, and red is over here. So that's our AM antenna. I'd like to just get this out of the cabinet, in other words. I've had no luck on soldering that negative lead over there, so I'm going to attempt to do it over here. We'll just get another visual. Well, the chassis is out. The hardest part was getting that power wire, or the ground I would call it, and the terminals off the speaker there, but we've managed to do it, and other than putting a tiny hole in our speaker there, which I may patch, our speaker is still good. Amazing. So our speaker is still good. I'll try and get a reading on that one-handed. Just take my word for it here. I want to put another hole in it. Yeah, I'm not going to be able to. This is like microsurgery. You'll have to take my word for it, but it reads 7. Let me get the camera over here for you while I do that, so you can see that or not. Got some glare going on. I'll go across the speaker terminals here. 7.4 ohms. So the speaker on the left that I wanted to use, 16 ohm, is open, so I'm not going to use that. We're going to use this speaker here. In 1968, a man walks into a shop that says radio repair and walks in with this radio, and guess what? It ain't going to happen. Yeah, it's a radio okay, but you're not going to repair it. Good luck with that. So, we have our negative attached. We're on 1.5 volts. Seems our on-off switch is now operational. I can't read the current it's drawing, but we have audio. Now, if we could only get it to tune a station, we'll look into that next. This is our area of battery corrosion here. It could be underneath this IF can, which that would be another impossibility. We have two resistors here we're going to check. And we'll check the bottom side of this circuit board there. So just like before, this is about all I can get out of it. Little audio hum in the speaker, but no stations. Continuing on here, we have an unlabeled broken lead off a disc capacitor here, but I don't think that's going to solve much of anything. We just need to find its value. There was still much alive around here, but no stations, so the quest is on to see what this disc capacitor was. Our broken disc capacitor here is C13. C13. C13 is a point. C13 is a 3? I am still nowhere, but I'm telling you, to get to the physical attributes of this, in regards to the layout attributes of this, the schematic representation of these IF coils, in this area right here, got to do some more cleaning and looking and cleaning and looking. Okay, from our stash from Radio Shack of ceramic capacitors, the closest I have is 10 and 7. So we're going to go with a 7 to put there, and I've just jumped in the electrolytic. I'm leaving that one in there. I'm going to assume it's dried up, but let's change a couple capacitors and see if we get wakey. Yeah, it really is a challenge. Everything you touch on here is crumbling. The antenna wire, we knew that was going to happen. Not all of them, but one strand here. We have our capacitors in, and we're still silent. But we're on. We're still tuning those stations. I think we've managed to actually mend our antenna wire here. I think it's scope time or something. Because we still just have there's no bridging. Still audio, but no radio. Still quiet. Over here there's one crappy, corroded, rusty, old 2SA34, I think it is, transistor right here. Oh God, how far do I want to go with this thing? It's got to be a transistor or something simple. Everything else looks fine. Well, we've checked our bridging, we've checked our connections, and we're still no worse than we are, but still no better. It's just not, it's just quiet. We're only talking 2 transistors here, the converter, a couple of IF transformers. Oh man. Jumped out C2. It's just so tiny and impossible to get to. Alright, that's going to have to do it for now. Again, it's just impossible to see the layout of these transformers on the schematic versus what they really are. 1, 2, 3, 4, 5, 2, no connection. And again, it's so tiny, you can't even begin to think where these are, but you can read them. They're just so impossible. Try a transistor, I suppose. Oh my word, even that is labor intensive. L4 is also suspect. That's the one with the corrosion going up the side there. I would like to be able to meter that one somehow. But again, it's just, they're just not like they are in the pictorial. Again, to try to meter those coils and figure out which leg is which of them, it's like near impossible, but we'll try it again. Okay, day 2 on the Panasonic R-111. It's easy to give up on these things, and I'm not as hardcore as some of you out there may be as far as these radios are concerned, but what's also the factor here is that it's so small and minute. There's so many challenges. Yes, it's a radio. It's very simple. The amplifier is working. Let's stop there. We've put one little tiny hole in the speaker with the soldering iron when we were disassembling it, but that's not a big deal. A little rubber cement will cure that. Just one little hole there. We've also broken one of the AM wires here, but it's probably corroded, but I managed to get a blob of solder on there. We haven't lost any from the core. That's the good news. Again, it's very tiny. We can go around and we can see, as far as IF transformers go, we can try to unravel the logic between the pinout, and I can try to get a piece of paper and draw them, but the IF transformers are tiny as well, and we're talking so tiny it's like near impossible to read the legs on them. I'm going to say 1, 2, 3, 4, 5 on that one, and then I can read them, but it's ever so challenging. Again, 1, 2, 3. So we can meter each IF transformer if we have to. It just takes patience and time, and it's just crazy. We do have oscilloscopes at our disposal, and I'm guessing, like I say, I'm not as hardcore, but I'm guessing super heterodyne, the mixer, and the antenna leads aren't broken, so we would have signal. We'll check voltages, but we should have a signal here. Some kind of signal here feeding the first IF amp. We also, I understand, the detector diode further on down the line, so I've jumped in another 5 microfarad here just in case, but that's so tiny and it would have to stay in the circuit almost because I can't get to it. But I've tacked one across there, and this 3 picofarad also broke, and we changed it with a 7 picofarad. That shouldn't change, but still quiet. So now I've gone ahead and I'm going to attempt, and this is another hurdle, is it has the 4 legs with the ground on it, the shield. So not only have base, collector, and emitter, we have the damn shield on here. So I've gone ahead and ordered, which I hope it's mislabeled, but it says Mitsubishi 2SA341. I am buying the mixer transistor only because I can, like I say, scope it and we'll meter it, but it's all rusty crusty up there, and it just doesn't look good. All right, and knowing the way this thing is acting, and without doing any real troubleshooting, I can do some voltages. Let me get some focus here. That transistor is terrible looking. I know looks don't achieve much, but when I get another one in my hand, maybe I'll take the tester and I'll test it. Then I will be inclined to attempt, as they pass them through the holes here, I think I have 1, 2, 3, 4 legs here. Tiny, 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 tiny. Everything in this is so tiny, 1966. It's unbelievable. I will just keep cleaning and trying not to break things, but we'll keep trying. All it has to do is come alive. And in the meantime, I may replace some of this hardened wire with something a little more flexible, because it's going to end up breaking off. But this thing is just challenging like no other. Here is our power lead. Here is our ground lead. We're going to have to put some new wiring in here as well. But if you can work on an iPhone and change the screens, there should be no reason other than the crumbling of parts here that we can't get this thing renewed somehow. But oh my word! And we have these transformer wires that are laid all over the circuit board here. They look like they'd short everything out, but they must be enamel coated, because that's the way they did it. And then we have to, once we get this breadboarded and working, if it works, we have to face the challenge of trying to get it back in the case without damaging anything. We had rubber shim in there that just fell apart. We have, but if they did it back in 1966 at the assembly line, we can do it. We're going to try. We are going to try. So we'll maybe play with this, turn the scope on, see if we get a little signal here. But I don't have the fancy equipment that some of you have. I do have a scope, and I do have a little tiny scope. We'll put something on there and see. And I have a signal generator. I could feed 455 into it. I just don't know what I want to do yet. Another thing, I'd love to have at my disposal a bunch of the Russian germanium transistors. Perhaps I should look into an assortment of them. But the thing with that is I could tack it in here to see if it makes the circuit function, but there's no way I'm going to get one of those in here. It's designed right around the style transistor that's in there, but I have nothing really to try. And seeing it's a mixer oscillator, they're fussy, so and again, I want to meter this IF coil. It's all rusty crusty. There's a couple resistors there I'm going to meter in the meantime. This is probably the deepest I've gotten into the front end of a little AM radio, and it's not that complicated. What complicates it is the size of this, but it's still a radio. Okay, welcome to Farm Radio. This is a quick update on the Panasonic R-111, and this is how far we've gotten. I don't know how much of the prior footage I'm going to include, but I was all over the place and decided to watch a few videos from All American 5 has one, and Mr. Carlson has one. There's a few others out there that explain the concept between the concept of these radios, and you know, the oscillator and the IF and everything. I've got my signal generator. Some folks have more elaborate equipment to troubleshoot with, and others just have not much, and we're somewhere in the middle. We've determined so far the IF is fine. It passes the 455 no trouble. We're at 1.5 volts over here, drawing about 20 milliamps. The problem seems to be, let me show you what it's doing. It's on. If I put my hand here. I'm going to set the camera down and maybe you can see, maybe you won't here. Alright, so here's what we got. I'll try and run down the readings for you here. Radio is on. If I put my hand over the antenna, I can tune stations, sort of. That station's right nearby. We have another one right there. It's like a 3,000 watt station. It's tracking properly. But when I take measurements, the converter is what I'm looking at. There's something wrong in the front end of this set. And it appears that possibly the voltage feeding the collector, which is right here, this is such a hard radio to find everything. I don't know if you can see the meter. The emitter is supposed to be a half a volt. It's minus a half a volt. It's minus 1. The base minus 0.8, almost 0.9. Hold on. Let me go back. The emitter here is minus 1. The emitter is supposed to be minus 0.37, about minus 0.4. It's reading minus 1. The base reading 0.8. The base is supposed to be 0.5. It's reading 0.8. And the collector over here that's where we're losing it. The collector is supposed to be minus 1.2, the full power of the radio, the full power of the supply, basically, and 1.28, and it's minus 0.1. There's no voltage on the collector of this transistor, and it goes through the oscillator transformer, and then through the first IF coil to pick up the minus 1.2 volts. So either the first IF coil is open or the oscillator coil is open, but the oscillator seems to be running. I'll meter the coils and that'll be the end of it. It's working, but it's not really working. Missing a... That's it for now on this end of things. This radio is so small and so tiny, it's like impossible. It will play. You have to hold your hand on the antenna. Just won't get the signal through. Alright. We spend as much time on this, it might as well be a 30s Philco cathedral, because it's just that much of a radio to try to find the issues with. I've drawn some pictures here to help with things, and when we're done we still got to try to fit it all back in the cabinet. I'm trying not to break the antenna leads there. The antenna coil is good. Drawing that out as well. So let me just go through the problem we're experiencing here. Let me get some focus here. So here's our antenna. Here's our base. The voltage here on the collector just appears to be absent. Comes down through the oscillator, comes up, over, and is connected right here to the primary of the first IF. So we're going to be looking in this area some more, concentrating. The IF is fine. The IF audio, all that is no trouble. It's right in here. I hope we don't have an open can, because these cans are minute. They're tiny, tiny, tiny. And this transistor is no picnic to try to figure out either. The tab is the emitter, base, collector, shield. I do have another transistor here. That's what I wanted to show you right here. I purchased. I don't think the transistor is the issue, but I do have one, and I just used it for lead identification. I don't know why it shows a diode in it like that, but that's what it does. Alright, that's it for now. Thanks for watching. Hopefully get this thing off the bench one of these days.